So containers are taking the world by storm. From the ocean to our laptop, to the on-prem data center, to the cloud environment, to the hybrid cloud environment, to the VM, they are literally everywhere. And it comes to managing, oh my goodness, do they need managing? Oh. Welcome from State Docker to Azure session. Today we are exploring how to deploy containers to Azure from our laptop just using a Docker CLI. It's a new beta feature that Docker is going to provide us moving forward, and I'm really happy to explore with you here as well. So let's try to introduce myself. Today I'm your speaker. I'm Saim Safdar. I'm a DevOps and Cloud Native engineer and also community speaker at Cloud Native Islamabad, where this session is being held. I'm living in Islamabad and also really uh, and I'm also using Docker, containers, Kubernetes, and working with these technology for more than 2 years from now. And really, I'm enjoying talking, learning, and also really enjoying when I speaking these technologies to peoples who are new to this stuff and who want to learn these technologies because they give us a new way of thinking about infrastructure and managing our apps. And in terms to how to get involved with these technologies, we have built a community called Cloud Native Islamabad, and we are we are related to anything about cloud native technologies. You can find we regular post things about cloud native and DevOps technologies on Twitter, LinkedIn, and Twitter and LinkedIn. And also we organize such kind of a session that gives you the insight what are the latest trend and what are the latest things happening in the cloud native environment. And if you want to learn more about these technologies, I highly recommend you to check out the community.cncf.io/Islamabad, where we held and that's give you where you know what are the new events that are happening in the cloud native Islamabad community. So I hope you can get in touch with us and give us a thumbs up on what we are doing here at our community events, and tell me about what you are what your current projects are and what you are doing these days, and which are the technologies you are love to hear about, and what are your problems you are facing day to day, so we can organize session as your need. So let's start the agenda for today's session. So today we're exploring what the Docker is if you haven't heard about it, and with Docker what the container is, how they help us moving from monolithic to microservices world, and if you doesn't heard about containers, we first spend a few times here. And also in the when you're moving to the microservices world, how Docker Compose is going to be help us is magic. It's really a magic when you talking about different services. It's a just one command and you get up to speed. And we are exploring how Docker new ACI integration can give us a flexibility to host our Compose app into the Azure as well, which is a kind of a beta in right now. So we're exploring that as well. So in exploring, we are also exploring the Azure construct, like what the Azure resource groups are, what the Azure Container Instances are. So what the audience for today's session? So I am hoping that some of the people that are managing the stuff of the managing kind of a different kind of infrastructure environment might be on their on-prem data center, or might be on the own public and cloud providers, or might be the hybrid cloud provider as well. So some of them you are wearing the offset and you are listening from, this stuff is for you. And some of them are just writing code and moving that code to the different environments with the help of ops people. And if you are listening to our session and you are currently wearing the dev hats, this session is for you. And one thing is to be noted: a best developer understand the ops, and the best ops people understand the developers. So whether you are ops people or whether you are a dev people, definitely this session is for you. So enjoy. So stay here till the end and enjoy the rest of the session. So what the Docker is? So Docker is essentially a tool that help my job easier when I want to deploy my application to different environment. So how to define a Docker then? So Docker is a tool designed to make it easier to create, deploy and run application by using the containers. Wow, what a definition is. So what is container then? So when I first learned about Docker, it's defining something and it's came into being a new term to me. So I'm really confused what this definition really means. So now let's what the container is. Containers allow a developer to package up application with all of its need, such as library, dependencies, configuration file, secret into one package. What end up Docker give me the flexibility is to give me the consistent environment when I'm moving from dev staging to production. So it gives me the consistent reliability when I deploy my apps to different environment using container technologies. So container is a de facto unit these days in order to package your app. So container is a standard unit of software that package up code and all of its dependency so the application run quickly and reliably from one computing environment to another. So container give us two features. One, it's run so quickly. Within a seconds, your apps is run, and within a second it's going to be down with no traces left on that machine, on that VM, on that infrastructure. And next, it gives the reliability when you're moving your apps from one source to the another destination. So you're not going to be caught up in any surprises when you're moving from different environments, and you're not going to be say that this app run on that machine. So that's a problem that container is going to be solved for you. So today everyone has talking about microservices, and if they are not using microservices in production, they eventually trying to or even they wish to do microservices. So containers eventually help us solve modernization with microservices using containers. So containers provide a standard way to package our application code, configuration and dependency into a single object. Because into the microservices environment, your apps have different dependency, different configuration and different secrets on different kind of libraries they needed to work efficiently. So containers help us isolate different services and give us a standard standard way to package our apps. And also they are the operating system installed on the servers and help us resource isolation, ensure quick and faster boot time, and also give us a reliable and consistent deployment, whether you are in the laptop or in the on-prem data center or in the cloud or in the local VM or in the VM that is hosted in the Azure, AWS, or GCP or Google Cloud platform. So when we talking about container, eventually under the hood they look like this. You run your apps inside the containers, and containers giving me these kind of things. Every container has its own memory, how much memory they are using, how much CPU resources they are using, what they have their own host name, they have their own ports, they have their own network namespaces, and they have their process ID, or what we call process isolation. So we have a same operating system with using the same kernel of that operating system, and then we virtualizes that operating system into, and that virtual operating system is used by different containers running on that machine. So the best analogy with container is, let's say we have a house where different brothers and sisters are living, and as a house we have a moderator, or what we call a parent. Is a parent can see the whole pictorial view of the house, what the resources their son and daughter using living inside that room, and they end up ensuring there is no resource conflict arising when their daughter and son using resources of that house. But the daughter and son, they see the only things inside that room. In with that they have the one they have with that they have privacy, and they have the isolation as well. So in order to remove the conflicts coming up between different sons and daughters, what parent doing, they provide an isolated environment for their children in order to do their task effectively. But as a parent, they see what's happening inside the room, what are the resources their son and daughter using inside that room. For the the sons and daughter, they think they are the only person living in that house, but for the parent, they can see the whole pictorial view of the house. So that's the best analogy you can draw with containers. So containers see what's happening inside the container, what are the ports they are using, what the process they are using, what the port network namespaces they are using, and they have their own host name as well. But for the main operating system, or the host operating system, or the kernel you say, they can see everything happening inside that operating system. They can see the process that run inside the containers, what the process they are using, how much CPU they are using, how much memory they are using, what the network namespaces they are using. So for the host operating system, they can see the everything the container are using. But for the containers, that's a very beautiful part of it. They can only see what are they running, how much, what the network namespace they are using, what the ports they are using, what the process they are using. And for the process, for the host operating system, they can see the whole pictorial view of the operating system. That's the best analogy we can draw with containers, are the family of the house and the family with the containers. So the best benefit we have with the containers, that application and its dependency we can define as a code. Yeah, we can define everything our application needed alongside its dependency using a YAML construct that we see later in our session. And also, it's really easier to manage microservices environment using containers. So one of the best advantage you can get with container is when you're using the microservices. And also, It's help you to standardize. It also enables you automate your testing and deployment because you have a standard package to work with. And it's also the consistent and reliable model because and it's help you achieve consistent monitoring system for you. And for the last, one of the best thing you can get with, you can define everything in a YAML construct in a coding language, put that into the resource repositories, let's say GitHub, and you can watch how your infrastructure evolve over the years from, let's say, day 1 to day 10, how the things evolve, because you everything what your infrastructure is now defined as in the code, and you can put security and compliance control to that. So these are the biggest advantages when you're working with container. So apart from that, one of the best environment advantage with the containers, you have to give up, you have achieved consistent and reliability when moving from different environment, from, let's say, development to staging to production, because you have to because you manage everything inside a single package. So when you move that container from, or if one moves your package from different environment, it's run and behave eventually the same, whether they are in dev environment or staging environment or in production. So typical container workflow for the dev people is, or for the ops people, is look like you have a Docker file. From that Docker file that written in a YAML construct that we see later in our session, and we build the image from that Docker file. We push our images into the container registry, and then we run our container out of that. So then what the difference between image or container is then and container? So eventually in the VM world, we have a virtual machine and its template. So a virtual machine is a running form of it, and template is a store form of it. You can say a template is a store form of a virtual machine. So in the same analogy we can draw with, so containers is essentially a stop form of image, or it's a stop container. So so the containers is eventually a runtime construct, and image is eventually a build-time construct. So what we end up with, I try to drive home here is, so in the object-oriented programming model, you heard about classes and object. So classes is a built-time construct, and when you create an object out of that, that's a runtime of construct. So for the class part, it's an image in our world, in the Docker world, and containers is a runtime construct. So container workflow for typically look like is, you have to build a Docker file, and then you build your images using Docker build command, and then you push your image Docker push command, and then you stop the container, run the container, or start a container. So first you have a Docker file, you start the command Docker build, so it's build your images, then you push your images to the container registry. In our case, let's say it's Docker hub, then we push the images, then we pull the images from Docker hub, and then we run the container out of that image using Docker run, Docker stop, or Docker start command. We can run the image container, we can stop the container, or we start the container. So we heard this term a lot. What the Containerized App is eventually an application that run inside a container. So essentially you have your app, you constructed a Docker file for that, and essentially it's going to be build that file for you, and you can run your app inside a container using that Docker file. So when we say what the container, my app is now a containerized, what I mean is your app is running inside a container. So in the VM world, we have a hardware, we virtualize is we virtualizes its CPU, its network, its storage, or its was a RAM or ROM, anything your hardware is running on, we virtualizes every part of it in a virtual world, VM world. In VM world, we can virtualize the whole hardware and providing a 2020 or 2025 or 3035 of chunk of that, and then eventually we deploy another operating system on different of chunks of VM, and then we deploy our apps. So it takes a really faster time to start up, and really where it take a longer time to even kill that VM or stop that VM. But in the container worlds, it's really interesting, because in the containers worlds, you're not going to virtualize the hardware part of it. You virtualize the operating system. You virtualize its process ID, its network namespaces, and its process isolation. Anything you have operating system needed, it virtualizes its part into the containers. So what end up we doing here is because it's using the same kernel or same operating system, so it's a very fastest to boot up, faster to kill down, lighter weight, and we can run many apps on one operating system. But in the VM world, because it's using the own its VM, it's using the virtual VM that's have everything inside it. Then we install application and operating system, so it takes substantial of 20 to 30 or 1 hour to take a time to start up. But in container, they eventually using the same operating system, so it's faster to boot up, it's faster, it's lightweight, and we can run many apps on single operating system. So containers are really helpful if you're moving your apps to containerize into the microservices world. So this is typically how the people are running their apps. Most of the people are running their apps nowadays. They have their own box. Everything, the DB, the secrets, the configuration, the reportings, the log part, and the different services your application needed, they are residing in the same box. And let's say you want to update just one service, let's say we call XYZ service. So you kill down the service, so you have to eventually tear down, or you have to stop your whole, let's say, a box, and in order to deploy the new version of XYZ service. And if, let's say, you have to scale individual part of it, you have to scale everything inside it. You have to scale DB, different services, reporting, everything in order to scale. So that's a really unreliable and inconsistent monolithic world where people are really struggling from over the year. So when you move to the microservices environment, you have different services. They end up running, or some services might be running in the public cloud, some in the hybrid cloud, some services might running in the on-prem or data center. So there are different services running on different setup, and they might be managed by different teams. Let's say reporting service are managed by this team, database is managed by different team, and for the front end managed by different teams, and for the third party integration services, they are managed by different people. But in the microservice world, one of the best advantage you can get, you can independently scale your different services. So if in order to scale, let's say front end, we don't have to even think about ABC service or XYZ service. Don't think about the reporting services. You can independently scale up or scale down your different services without even affecting that whole infrastructure. That's the construct that you can draw with. So that's how from the monolithic to the microservice journey look like, and these containers are going to help you a lot. So when we talk about how the monolithic world, we talk about microservices. So how Docker help us achieve run multiple apps on it. So we have a Docker Compose file. So we first that's a YAML file we are talking about. We have everything inside it. So that's a compose file written in YAML construct. We define a version, and now we define the services. So my app has now, let's say, front end, and it's built from the front end. If its front end is exposed and port 8080 outside, and it also run inside the container as in port 80, and it depends on the backend service, and backend is built from front end. So that's a whole part of it. So we have two services that my app needed, front end and back end. So in order to work front end startup eventually, it, let's say, just start the backend service first in order to front end working properly. So that's a Docker Compose file, and we learned about that we are Docker help us achieve microservices environment. So this one file 4 or 5 or 6 or 7 line, we construct a different services that are residing in, and we provide a YAML construct for that, and they are containerized it as their different individual services writing on different hosts. So Docker Compose is really help you in setting up deployment development environment if you want to automate your testing on different environments, and it's a single host deployment. These are the common use of the Docker Compose file, and this is how Docker Compose, or you can work with Docker Compose. So in the Docker ACI integration that currently have, they not give us so much flexibility of running the compose file of it, but the new Docker ACI integration really help us do. So let's say we have a different environment, different setting up, we have a Docker Compose file, we just say Docker context use in my Azure context, and they have eventually deployed that to us, and that we are going to be seeing next. So when we deploy our containerized app into the production, into the Docker, we end up doing is we say Docker Compose app, and is eventually deploying the resource group, task definition, identity and access management, Azure Container Instances, application load balancer, security group, log groups, everything. So eventually is now in this beta group, they give you the flexibility to deploy existing resource group that you already have. If you doesn't have a resource group already in the Azure, so they can build from the Docker CLI from you, and then eventually it deploy the container in Azure Container Instance for you, and they give you the IP you can listen from. So let's start our demo. Our session is now. But that's, I think you are all waiting for what the new integration with Azure ACI with Docker is look like. So we are just going through this session on this Docker blog post that is coming from Peter McKay from July the 13th, and from that we are just going through this post and eventually to how to deploy the Azure app, and then we deploy our own small apps into the Azure using these familiar command that we see from here. So in that, what I do here is, if you want to run on your laptop as well, you have to download the latest version of Docker, has to be in your laptop. So that's a useful link. I put them in the chat as well on here on YouTube, so you can get it. So you can download from the Mac or Windows. For this to work on your laptop, you have to have 2.3.0 or 5 or later version of your app. Windows Docker is available for you, and you can go through that. These are the command, and they give you the insight of what are the things you can do with right now, do with you. So previously we look at, when I try out, we don't have the leverage to expose our port. Let's say we can see from log 8080, we cannot map the port into the Azure, but let's say can we do it now, right now, or not. So there's so much uh, uh, things that we want with this integration to have all volumes. I want my uh, we can have a storage account, we can use different kind of, so I see where it goes at the time, the Docker, the ACI, because we need to have a port mapping, the storage of some storage provisioning capabilities. I want my, so right now they're doing to look container images from the Docker hub. I want these to be looked at the Azure Container Registry as well, or some other part of it. So there is so many things. I think I want to, we have to think, we have to see where it's going to look at. So without wasting any more time, I just want to say, if I have free time, going to look at it, because every now and then this kind of integrations, because Docker has integration with Azure is Azure, and also you have integration with Docker ECS, that is Elastic Container Service in AWS as well. So there's so much more that is coming out in more months as we're going out. So this integration is now since DockerCon 2020, that's virtually hosted in July of something, some date. So right now there is, I see some few more things coming up, like using Azure file share volumes as well. So we have to, I have to take a look at how where it goes, because as a developer and a boss, we want so many things, because this feature is so essential. If you doesn't know about Docker, Azure particularly, if you don't know how Azure works under the hood, so Docker can do that for you, and you don't have to think about how, what are the resource group and what are those kind of things as well. So a part of that, about that, we are going through this blog from Docker and running the stuffs that is listening here. So first thing, we have to run the Docker login Azure command here. So I go back here, so I run Docker login Azure. So it's going, it's directing me, I'm going back to the browser and sign in with my own credential. So eventually I going to be succeeded there, and then eventually I am able to run. So I'm successfully logged into that. So next up, I have to see what are the contexts I have right now. So contexts are the different cluster you have already available in your machine. So I have one cluster that is available on my machine that is called default, and that one is for Azure. So how I create that, I going back to the blog here and I run that command to see the Docker cluster I have available. So it's helped me to, and next I have to create the cluster like this way. I'm going back to paste this command. So it's helped me create a new cluster. So this cluster is residing in the Azure context command. That's the integration that we are talking about. That's a new command in Docker. You can create the new Docker create new context. I'm name that's context called ACI. That's for Azure Container Instances, and you can name your context already there. So I can run already command this. I name my cluster my ACI. I'm ran previously. So I can list my cluster, so you can see I am currently in the default cluster. So let's now move into the ACI context. So now if I can see, going back to the command context ls, I'm now into the Azure context. I am, and in this context you can see what are the command you're going to run. That you can you can deploy your Compose app into the Azure. You can have a context in command. You have ECS like Azure Elastic Container Service integration with Docker. You can execute with, but you can't build the images in that context, because that's going to be very, because in that context you don't want to build the images, you deploy the images to Azure. In the default context you can build the images, that context the default, that in the Docker cluster install, and then when you already done with that, you're going back to this context and you can push the images. So right before, you can't build the images in that context. What you do is you can going back to the your own command and use the default context and then build the images, and then use the command for this, come here, back here, and then deploy to the Azure. So now we deploy the sample app that was here. So we end up doing all of the things. So now Docker context. So if I create the context here, so it's going to end up see a resource group inside the Azure. So I already have a resource group that's called Docker demo. So it's going to be deploy the container into that. So if I can use this command, Docker context create ACI, my ACI, it's first create the resource group and then it's eventually deploy the containers on top of it, because Azure are going to be using that kind of a thing. So now I'm going back to here and use this command now to Docker context my ACI running in a detached mode, and give it a name of container web. And now I try to publish a port here. Inside the container I can log in, access the port 80, and outside the container I'm also running the port 80 as well. So now the name of the image is nginx. So once I'm now deploying into the Azure, so that's how it's going to be seen when you deploy your container to the Azure. It's a time base, is see the visual how long it takes to deploy the containers to the nginx container into Azure, and it's eventually, I see it took more than 20 to 30 seconds. It's going to be deployed into the Azure, and when it's deployed, we're going back to that resource. It give back me the IP as well, and I can use that IP to see what the containers is what the container is look like. So that's the blog post. I put them into the chat as well. You can run that as well. And so in order to switch the context between different you use the command Docker context use my ACI, and Docker context use command to switch different contexts from default to ACI. So that Docker context command, I think, is coming from Docker version 1.12 or 1.14. Ever since it's going to be a really easy to work between different, you can say, on different namespaces on different cluster. So it's a very helpful command inside. So it's going to be hosted inside the Azure. Let's say what are we running inside the Azure Container Instances. So if I grab this URL, and going back to the port 80, end up to welcome to the nginx website, and that's running inside the Azure. And if we go back to the Azure and going back to the Docker demo, it's deploy the Azure Container Instances over there, and all the things is deployed under the resource group called Docker demo. So that's where I have a new Azure Container Instance is available for me, and I can deploy the container. So it's deploying the from just using a Docker CLI command is deploy the container over there. So here's our containers are listing here. So I using the Docker container web. Name of the container is web, nginx, state is running, previous state is nothing, how long it takes time to start up, and how much the restart count. Here's the overview, here's the activity log, what's happening inside the containers, what are the, here is IAM control for the containers, here's the tags for the image I am using, monitoring alerts, everything. Here the tasks that my container is using, all kind of a cool stuff doing that for me for the Docker CLI. And here's the IP that they give you. So that's the cool stuff. And what if I can you can stop the container from here as well. So I stop the container, and if I going back to here, it's not going to be, it's take time, and eventually it's not going to be responding. So now we can see it's going to be in a node stopping state, and if we take some time, it's going to be not available for us in the browser. And you can also remove the containers inside the Azure that we can see in the portal here. And if we use remove the image there, it's going to be deleted from Azure Container Instances, and it's not going to be deleted the resource that is already having it. So now let's say we remove the image because we're using the existing resource. If we created a new resource inside it, its resource is created, is deleting the resource and everything inside it like in Azure Container Instances. So let's say we remove the image from here. So it takes some time to remove it from, because it's going back to the Azure and it's going back to delete it from the Azure. So now if we go back here, Docker ps-a is going to be see all the containers I'm already currently have. So now if I'm going back to the app, it's not going to be available for me. And also if I'm going back to the Azure, it's going to be deleted the Azure Container Instance from that. So let's explore that as well. I'm going back to the home and refresh from here. So now I don't have any, I don't have any Azure Container Instance is listing inside of a Docker demo resource. So that's the existing resource I have currently available. If I initiate a resource group with Azure, so it deleted the resource group as well, but it takes some time. So I have already Docker demo resource. So inside the Azure Container Instance is deleted and removing everything from you. So it is going to remove the hassle of you, so you don't have to be forgetting to remove the container and anything. So it's going to be help with that. So now for the last part, let's use our demo. So that's, I have a Docker, previously we look at Docker blog and run a small images of that. So I have it build this Docker images locally, and that's the Docker file we are talking about in our slides. So it's everything inside it. And when I move this Docker file to the different environments, it's behaving the same as it's running in my local machine, whether I'm running in the virtual VM or the VM in the Azure or anywhere. So I use, so before that, so I if I going back to the default context, I have the image available for me. So I previously run the image. If I can type properly, we should. So this is the image I am previously built. This is the image I previously built, and it's already available on my machine. And also if I go back to the Docker CLI board, I'm also deploy back to the Docker hub as well. So it's grabbed the images from the Docker hub and deployed to the Azure. So if I'm going to the remote repository where I have my images available for me. So there I can list my images there. I have a no Docker ACI demo, and I can going back to the using the view in the Docker hub as well. So that's a doc is available for me, and if I deploy into the Azure pull the image from Docker hub and deploy into the Azure Container Instance on behalf of me. So I previously ran this command, so now I'm going back to just grabbing the name here. And going back to the context, use my ACI. And now if I docker run -t -p, it's running on port 3000. How I know that? Because if you're going to the config.json file of this code, is hosted at 3000 port over there, and so that's the file, 3000 ports in which the container is hosting. So let's say we say 3000 of outside and 3000 inside the container, 3000 inside the container, and giving them back the name of the image. So it's now running inside the Docker. And now we are pushing our image, our local image, inside into the Docker container, into the Azure using the using just a simple command. Without this integration, what are we doing? That we are pushing the image into the Azure Container Registry somewhere, and then we log into the Azure and do some time of clicks into the Azure board, creating a resource group, all kind of the IAM policies, Azure Container Instances, everything we're creating all on behalf of we doing and Azure, and then we deploy our everything. But in that Docker CLI integration, we're just running the command, and it's going to be building everything what we needed to run our app inside the Azure. So that's a very cool integration, and that's integration really helpful if you doesn't know about how the Azure works, because containers have a steep learning curve, and also the Azure have so much to unpack. So some of the people don't understand the Azure and Docker, how they do it, how do they run their application on top of it. So they end up doing, so Docker help you if you doesn't know the knowledge of the Azure or cloud provider. So in there, Azure help you just using the CLI, switching to the different contexts, creating a different context for the Azure, and when the context is creating, switch to the next context, run the image, run the container, and that's eventually they push for you into the Azure portal, and just under 1.5 seconds you're going to up to the speed. So now if I go back and run a command docker ps-a, and remember we are inside the Azure Container Registry, and now we have our local image that is on this IP. And if we go to the might be is 20. So here our app is running inside an Azure. So that's a small app of a Node app. That's a really small app just for the demo purposes. So welcome, so just say welcome to the cloud at Islamabad and join our Discord, LinkedIn, and blah challenge. So that's a very small app that's written for this demo. So it's a very cool feature of Docker. I really like this feature, but we have to think how far this apps to be going with Azure, because we need now, if this kind of a feature giving to us by Docker, we need to give some kind of a volume support as well, so we can have a volume our container is using from our local machine, and they have to be going back to the Azure file disk or some kind of. And we also need a support for moving the container to the Azure. We have a CLI support whether I want my container into the Docker hub where ACI is watching from, or it's going to be Azure Container Registry. So much things that I think in future we'll see this integration give us. So hope this gives you a very good familiarity. So one thing I don't run in this demo is the Docker Compose app. So you can see a Docker Compose command, not with Docker dash compose, but it's a Docker dash compose. So that's the command you're going to be use, and it's going to be build the images for you. But I'm not going to be using that for today's session, because right now it's not a production scenarios kind of a stuff that is going to be used. It's a very demo purpose app. So I hope I try to build some useful app, Docker Compose app for you guys. And if you want to be work from there, you can see how the production kind of a scenario works with Azure Container Instances for the using the Docker Compose. So rest of the part is going to be homework for you guys. So you're going to be start from, and this is a very good blog post, but something in the code is really bad and it's not running when I tried out. So let you try out this post, because it's going to be and that GitHub repository for you guys to work with if you want to follow along this blog post. But it's not going to work in my machine or my setup. So I try to figure out, speak about little things, but it's not going to be very production kind of a scenario. So I try to build a production based Docker Compose file, and I try to share with you, and hopefully today what we have covered give you the feeling of of what the container instances are and how Azure is works. So let's say, and now if I going back to the home and going back to the Docker demo, and the last thing we're going to look at is eventually is giving back the Jolly Joe Goldstein app for the Azure Container Instances, and that's where our application is running inside the Azure. That's the public IP, and that's where we're listening. Our application is hosting to the Azure. So hopefully this is going to be a very good, it's going to be see how much memory we are using, how much request is going on, what the network bandwidth, some all kind of thing. And that's the containers are, what are the containers we are using. I'm using the container that is hosting on the Azure Container on the Docker Hub and ACI Azure Container Instances, pulling the images from there and running my apps on top of it. So I'm not going to be uh, doing the Docker Compose thing for this action, and eventually I'm going back to the new session entirely on Docker Compose, and hopefully today you'll learn all the cool stuff from today's session. So So that's all the things I think we need to cover for the today's session. I put the links useful for you. For the first link for the Docker blog post, what you need to uh, so I definitely recommend you to try everything that we covered today and run on your half. And if you have any question, good questions, uh, definitely reach out, put them in this chat, and eventually tell us what this feature look like for you, and is this feature is currently help you in current scenario in your product in your current production scenario. And to help to connect with Cloud Native Islamabad and community.cncf.io/Cloud Native Islamabad is where we post our sessions, and we are in a hopefully you can see the things that you are working currently on, and we're doing a great demo session on that. So with that, if you have any question, put them in the chat, connect with us with our Twitter, LinkedIn, and community.cncf link, and uh, check every now and then what's the new session are coming up. And we are building a next session hopefully in Azure Kubernetes service that going to be in the 1 week from now. So uh, stay till then, stay safe and stay strong, and happy Docker.